Students, today we're going to be factoring trinomials and we're going to learn a method called the AC method. But first, let's look at a trinomial. Here we have an example of one right here on our front page. In front of each of these trinomials is actually a coefficient, A, B, and C. In this case, A is just 1. But we need to learn to identify what A equals, what B equals, and what C equals. And in this case, it's just the form for it. It's called the standard form of a quadratic. But we're looking at that today, and we're going to learn to identify A, B, and C. If there is an A, it's always if there's nothing written in front of the x squared, A is always 1. Okay, so we'll learn to identify those, and then we're going to learn how to factor um, using our factor by grouping that we learned yesterday. And I might even teach you what we call synthetic factoring. So hold on, here we go. So we're going to learn to factor trinomials with leading coefficient of 1. In other words, the A is 1. And we're going to factor out any common monomial factor. So the first thing we always do is look for a GCF. Okay, so in this one, we notice that our leading coefficient is 1. So that makes that pretty easy to factor. And so what we do is A is 1, B is 8, and C is 12. And we're learning to identify those. And we're going to factor this. We have to look here at 12. 12 only has 3 pair of factors, like it says. And what we're looking for, maybe some of you have seen this before where you had a teacher who wrote an X on the board. And we're looking for something that multiplies to 12 but adds up to 8. So what that really is you make an X, and it's really A times C goes here, and B goes here from our things here. But 1 times 12 is just 12, so that's why that's there. And B is 8. So if we could, we would just like take a bunch of trinomials, and I'd just have you identify A, B, and C, and then put A times C in this upper part of our X and B in the bottom time of the X. And then we ask ourselves this question: what factors of, in this case, 12, because 1 from the A was 1, times 12 are 12, but add up to 8. And so, well, 1 times 12, that does not add up to 8. 2 times 6, that does. So I could say 2 and 6 could be factors that add up to 8. The other factor is 3 and 4. 3 plus 4 does not add up to 8 in any way, shape, or form, even if it's positive or negative. And so we would say, okay, well, we're going to use the factors 2 and 6. And because our leading coefficient is 1, we can just say that our factors are then x plus 2 and x plus 6. And we would get our factors like that. And that would be factoring this. Remember, when we learned to multiply polynomials, binomials, and we would end up with the trinomial, we're just breaking it apart, finding out what its factors were originally. There is another method I like to use, and you do not have to use this, but it's kind of what I call the box method. And it's the same, it's just a different graphic organizer. Oh, well, that's beautiful. There we go. And I always put A times C here and whatever B was here. And then this would be the factor 1, factor 2. I used that because I had a worksheet that a lot of kids we would fill that out just looking for what numbers multiply to whatever was here, but add up to here. And then we say what those factors were. The X still works the same. Most of you have probably just seen the X. So we're going to forego doing the graphic organizer that way. We're just going to keep it this way. Okay, making that X. The program here that I'm using, they like to just show the factors 1 times 12, 2 times 6, 3 times 4, and those would be the factors that would make a positive 12. There could also be a negative 1 times a negative 12, negative 2 times a negative 6, and a negative 3 times a negative 4. But negative 2 plus a negative 6 add up to a negative 8, and we have a positive 8 here. So how I know what kind of factors to use is, first I look at this term. If it's positive, Well, first look at this one. If this is positive, I either have both factors are positive or both factors are negative. Though I would use the negative ones if this was negative. But since this is positive and this is positive, all my factors are going to be positive. So we're going to learn, we're just going to get a lot of practice doing this. So if they show you the factors, you can go through them in your head or you can write them out here, and they recognize that 2 plus 6 does equal 8. And so they can factor these as x plus 2 and x plus 6. And the only reason this works like this without factoring by grouping is because a right here, the coefficient in front of the x squared, is a 1. Okay? So if the middle term had been a negative 8x, then we would have wanted the pairs of negative factors. So we would have used x minus 2 and x minus 6. So let's look at here. We have a negative 20. What kind of factors would I have to make a negative 20? Well, one would have to be positive and one would have to be negative, wouldn't they? And then I look at my b. My b is a negative 8. I know that the larger of the two factors will be the negative. Since this is negative, the larger of my two factors are going to be negative. So let's start thinking of factors that make 20. Well, there's 1 and 20. 1 times a negative 20. But that only adds up to a negative 19. How about 2 times a negative 10? If I add those up, that equals a negative 8. And that's what I'm looking for. So I'm going to put the 2 here and the negative 10 here because it's the larger absolute value, okay? And so that's what we're going to use. So the negative 10 there. And now because my a is 1, and only because a is 1, I can just write my factors like this. Each one get a y, and then a plus 2, and a minus 10. And I am done. Using what we call the AC method, where 1 times a negative 20 is a negative 20. That's why it goes here. B always goes right here in the bottom part of the x, and then our factors here. We have to determine which one gets the positive, which one gets the negative. If our a times c is negative, then one factor is positive, the other factor is negative. And if this is negative, the larger absolute value goes to the negative. Okay, so let's try another one. Let's get rid of this. Here they're going through the list of all the possible factors, but there's only one that works out here. And you don't have to write all those lists if you can kind of see them quickly. Okay. You could try it trial and error, and that's okay, but it's best to kind of maybe make a chart or at least know where you're headed with this, okay? So they figured out it was y plus 2, y minus 10. It doesn't matter if we write y plus 2 times y minus 10. We could also write y minus 10 times y plus 2. It's the same as saying, is it 3 times 4 or 4 times 3? They're both going to yield us the same answer, which is 12. So here are the rules of factoring trinomials. If we have x squared plus bx plus c, it's possible to find an integer pair of factors of c whose sum is b. So if c is positive, here's how it works, then both factors must have the same sign. So they either both will be positive or they both will be negative. Okay? So if b, the b part, is positive, both factors will be positive. If the b is negative, both factors will be negative. Okay? Now, if C is negative, then one factor must be positive and the other negative, and you're going to find out by, you can trial error, or you can kind of think, okay, well, my B is negative, so my larger factor needs to be negative. Let's look at this one. Now, the first rule of any kind of factoring is to find a GCF. That's the first thing you should do every single time. So let's look at this. And what do we have in common? It looks like a 5, 15, and 10. I have a 5 in common, and I have an x in each of those. So I'm going to factor out a 5x. And what leaves me is x squared minus 3x plus 2. Now, this is the part then that we're going to see if we can factor some more. So let's make an x. And my c part is 2. And my b part is a negative 3. Now, if C is positive, but B is negative, both my factors must be negative. So what are factors that make 2? Well, there's only one set. It's a -1 times a -2. And do they add up to 3? Yeah, they do. They multiply to 2, but they add up to 3. So these are my factors. And so I'm going to rewrite this part right here. This part right here. It's going to get rewritten as the factors x, we're using x, and then -1 and x minus 2. And don't forget to bring down that 5x, because if I ask you to factor it completely, I need to see that. And so the whole correct answer is that. And then they do the thing, they figure it out like we did. Okay, so what's our first thing that we do? GCF. GCF. You're going to say that every time. Did I find the greatest common factor? So I look at this and I'm looking, well, there's a 10 and it looks like I can take a y third out. So 10 times y to the third, and that leaves me 2y squared minus 2y minus 8. Nope, not 2y squared, sorry. I took that out. It just leaves me y squared because I took a 10 out. So that's y squared minus 2y minus 8. And now I'm concerned about this part right here. So I have a -8 here and a -2 here. That tells me I'm going to have a positive factor and a negative factor. And because my b is negative, the larger factor is going to be the bigger absolute value number. So factors of 8 are 1 and 8. Well, 1 times a -8 is a -8. But 1 plus a -8 equals a -7. So that doesn't work. So my next one is 2 times 4. And so the 4 will be negative. And what is a 2 plus a -4 equals a -2. And that's the one. So I'm going to use a +2 and a -4. And so when I come over here to factor this, and I can do it because a is 1, when I took out the GCF, what was left here was just a 1. I get y minus 4 and y plus 2. And that would be our answer. And not completely, though, we'd have to bring down this 10y, right? And that whole thing is our answer. So they factor out the 10y third just to see it one more time, leaving us y squared minus 2y minus 8. Factors of a -8 are -4 and 2 that add up to a -2. And so they can factor that. And there's the final. When factoring polynomials, always look for a common monomial factor first. Always, always, always look for the GCF. You'll save yourself so much time that you'll be like, oh, I'm glad I did that first. Not all polynomials are factorable. When you get to this stage right here, and you see that it's x squared plus 3x plus 4, that is not factorable. There's nothing that multiplies to 4 but adds up to 3. The positives. And so you would just say not factorable or irreducible. Later on, and you get to 1010, you're maybe going to learn how to factor that, but not right now. All right, that's the end of that. So today's factoring occurred just for polynomials. We're doing binomials, trinomials, degree 2, whose leading coefficient was 1, so the a was 1. And that's all we did today. So hopefully you can get some practice doing that. We do have an assignment coming up, a participation assignment where you're going to get lots of factoring practice. So I would suggest starting on that today, start on it today, because if you can, there's going to be some polynomials that are just like that with just one that you can do. Okay, where a is 1. and you can factor it that simply. So good luck on this, and we'll see you later.